We are discussing about CBSE Standard 12 Physics previous year's questions answers. This chapter belongs to electronic devices. Okay, so let's resume our discussion. First question: describe briefly with the help of diagram the role of the two important processes involved in the formation of p-n junction. Okay, so we know that a p-n junction is basically a device which acts as a diode, as a bulb. Okay, so one type is p-type, one side is p-type, means added with, doped with a trivalent element like aluminium, where majority charge carriers are holes, and on the other side it is doped by the pentavalent element like phosphorus. Okay, so it is where the majority charge carriers are the electrons. Okay, and this is the region called the depletion region, where some of the electrons diffused, and because of this hole it comes to this side, these holes, these electrons from the p-type, it comes to this side, and the holes also because of electron comes to this side. This is called the depletion region. Okay, so let's see. In the p side we have higher concentration of holes. Holes are the majority charge carriers, and in the n side we have the higher concentration of electrons. Therefore the diffusion of holes, that is electrons, to the right of the junction may fill up the vacancies to the left of the junction. Similarly, because of concentration difference, conduction electrons diffuse from the right to left. This makes left half positively charged and right half negatively charged. Correct? Now, electric field will be created from the right to left. This is the electric field. E is the electric field. So this electric field is created from the right to left. This. Okay. Holes will be pushed to the left half, and conduction electron pushed towards the right half. Correct? Conduction electron pushed towards the right half. This region where no charge carrier remains is called the depletion region. This region is called the depletion region. Now we will define certain terms like what is diffusion current, what is drift current. Now what is diffusion current? Because of the concentration difference of holes having higher kinetic energy can cross the depletion region by overcoming the force due to the electric field. Similarly, diffusion electrons from the left having higher kinetic energy can cross the junction opposed by field. The current, the electric potential of the N side is higher than that of the P side. Okay. This is N type basically. This is N type. And this is P type. Okay. So there is potential barrier at the junction which allows only small amount of diffusion. Okay. So this, because of this depletion region, small amount of diffusion takes place. This diffusion results electric current from P side to N side, and this is called the diffusion current. Okay, so in a p-n junction, because of the diffusion, some of the electrons crosses this barrier, and comes to this side. Holes crosses this barrier, comes to this side. So electric field is set up. Okay, electric field is direction of electric field from positive to negative. So this is the direction of electric field. This point is clear. Now what is drift current? Thermal collision results breaking of covalent bond and electrons jumps to the conduction band. Okay, so in the band theory, we understand what is conduction band, what is valence band. Okay, so electron hole pair gets created. Also, conduction electron fills a vacant bond and electron hole pair is destroyed. These processes continue in every part of the material. So we will explain in a separate question where we explain actually conduction band, valence band, the gap between conduction and valence band, why some of the element behaves as a conductor, what is the difference between conductor, semiconductor and bad conductor in terms of band theory, correct? So there we will explain all these things, but for this question and answer we will be very specific. However, if an electron hole pair is created in the depletion region, electron is pushed by electric field towards the N side and holes towards the P side. Okay. Now, thus there is a regular flow of electrons towards the N side and holes towards the P side. Okay. This generates current from N to P side called the drift current. So N to P side, the electron will continuously flow and this will create a current called drift current. Now, second part of the question, name the device which is used as voltage regulator. Okay. Now, normally what happens when the P type is connected, suppose this is P type, this is N type. Okay, P type is connected with the positive, N type is connected with the negative, then this is called forward biasing. Okay, but in case of voltage regulator, instead of connecting the P type with the positive, we connect P type with the negative. Okay, P type with the negative terminal, and N type with the positive terminal. This connection is called the reverse bias condition. So a voltage regulator operates in a reverse bias condition. The type of device used in reverse bias condition is called the Zener diode. Okay, avalanche is created. Now we will understand this device called voltage regulator. Draw necessary circuit diagram and explain its working. So we will understand fully now what is Zener diode, how it operates in the reverse bias condition and its circuit diagram. Okay, so let's explain this Zener diode part. So we know that as the voltage increases, applied voltage between the P and in the forward direction, when P is connected with the positive and N is connected with the negative, okay, then this is called the forward bias. So if you increase the voltage when it is operated in the forward bias condition, the current also increases. So this indicates this current. So voltage versus current is not followed by Ohm's law in case of semiconductor. It is Child-Langmuir's law. So this region is clear. Now, if no voltage is applied, if you decrease the applied voltage in the forward condition, the current reduces. But now, if you reverse this voltage, means P type with the negative and N type with the positive. P type is a negative and N type with a positive terminal. When it is reversed, then what happens? After some time there is a sharp increase in the current. Okay, this is called the reverse bias condition. So this is the Zener diode symbol in the circuit. So now this is the load in the circuit where we find out the output, and this is the output voltage. Okay, this is the input voltage. This is resistance in the circuit. So this clearly indicates a load is connected to the Zener diode, and to regulate this voltage we have a Zener diode. So how it works, let's see. When the reverse bias voltage across PN junction diode is increased, means continuously you are increasing this voltage, correct? Negative voltage. At a particular voltage, this voltage, at a particular voltage, the reverse current suddenly increases to a large value. This is called breakdown of diode. Voltage is called the breakdown voltage. So it breaks down. In this voltage, the rate of creation of whole electron pairs increases. Thus, current increases. Okay, a kind of avalanche. Avalanche means sudden increase of current. So the sudden increases, suddenly the current increases. So Zener diode is connected to unregulated DC voltage. Zener diode is operated in a reverse bias condition. This is also correct. The current through R and Zener diode increases as the voltage increased. This is also true. The current through the diode increases, but the voltage remains constant. Okay. The voltage remains constant in the breakdown region. Okay. So at a particular voltage, this avalanche happens because now we are not increasing the voltage, but the current increases, correct? So this happens at a constant voltage. Now, the current versus voltage characteristic in graph shows voltage VO across the load RL, that is constant. If there is a small change in input voltage, the current through the load, RL is the load resistance, remains same. So this is how we have to explain the Zener diode. This is the circuit diagram. It is operated in the reverse bias voltage. Okay. And why there is sudden increase? That is also explained in my last answer here. See, current. So this condition, the creation of whole electron pair increases because of this reverse voltage applied. Okay, so this answers, you can take the screenshot. Okay, now let's move to the next question. Explain briefly the principle on which transistor amplifier works as an oscillator. Draw the necessary circuit diagram and explain its working. So we will explain now how a transistor. Transistors means it can be NPN or it can be PNP. Okay. So how a transistor works as an amplifier. Okay, and this is the work of an oscillator. Now draw the necessary circuit diagram and explain its working. Okay. Now let's understand this. What is oscillator? Oscillator is a device which converts DC power to alternating power in a desired frequency. So this is the input is DC, okay, and output is, this is the input and the output is AC. So the device which takes the input as DC and converts it into AC is called oscillator. And what is the opposite of oscillator? That is AC to DC conversion, that is called rectifier. Okay. So oscillator is a device which converts in DC to AC. Let's understand the block diagram. In this block diagram, we have a transistor amplifier. So see, just now a portion of the output is fed back in phase to the input. See what is happening here in this block diagram. Now this is the input voltage applied, this is the input voltage applied. Okay, this particular box indicates our transistor amplifier. So the input goes here. This comes as an output here. Okay. Now we are giving this output. A part of the output is fed back to this circuit again. Okay. This is called feedback network. So again, this output obtained is supplied as input here. See, this is again supplied to input. This particular network, this particular device, this is called the feedback network. So if we have to understand that this process of taking a portion of the output and again giving it as input is called the feedback. Amplification is done by amplifier circuit. Okay. Amplification means, suppose we have a small voltage applied. Okay. The output is a very high. Correct. For a small change in the input, the output amplified. This is the purpose of amplifier. So amplification is done by the amplifier circuit, common emitter transistor. Okay. Emitter is common to input as well as output, common emitter circuit. The feedback is done by tank circuit. So for objective type question, these are important. What is oscillator? How amplifying is done? What is the feedback circuit called? Okay. Now let's understand the circuit diagram. Okay. So this is the symbol of our transistor. Transistor has base, transistor has collector, transistor has emitter. Correct? Now IB means the base current, IE means the emitter current, and IC is the collector current. Okay. Now, so see here, inductor LC circuit is provided. Okay. So this is the battery to drive the input voltage, and here we have B2 means source of voltage. Okay. And how to means it will convert. This is the transformer basically. Transformer is a device which actually based on the principle of mutual induction. Okay. So when current flows from one coil, okay, the EMF is induced on the other coil. Okay. This is how the transformer operates. So let's understand. The basic parts of the circuit are amplifier and LC network. LC network means inductance capacitance network. The amplifier section is a transistor in common emitter mode. Why common emitter? See, if you see the circuit, this emitter, this is the emitter. This emitter is common to the input circuit, this circuit, as well as this circuit. That is why it is called common emitter. Okay. And LC network is simply consists of an inductor and a capacitor. Okay. Change in current is due to the change in magnetic field in inductor and electric field across the capacitor. Batteries are used to bias the transistor. Okay. Biasing means applying voltage. Now a part of output signal is returned back to the input section after passing through the LC network. This is called feedback. This signal is amplified by transistor and a part is again fed back to the input section. Thus, it is self-sustaining device. Self-sustaining means output is fed back to the input circuit. That is why it has a continuous flow. The component with the proper frequency nu0 gets resonantly amplified here is the term resonantly amplified, means at a particular phase, at a particular frequency, okay, amplified, and the output acts as a source of alternating voltage of that frequency. The frequency can be varied by changing the value of inductance and capacitance. Phase shift of 180 degree is made by common emitter amplifier. The frequency of oscillation, as you know, the resonant frequency in LC circuit is how much? Nu 0 is 1 by 2 pi root over 1 by L into C. Correct? This is the resonant frequency. So for this, we will explain actually this amplification. This is actually the working of feedback circuit. That's why we have to restrict to our answers only. So you go line by line, study it. So this much you have to produce in your exams to answer this question. Okay. Now, identify equivalent gate. Next question. Equivalent gate for the following circuit and write its truth table. So this is how is truth table given. Okay. So this is A and truth table means A and B as the input. Though this is the symbol of NOT. So if 1 is passed, output becomes 0. If 0 is passed, output becomes 1. Similarly for this also, B is 1, then after passing through this gate, it will become 0. It just reverses the signal. If it is 0, means low voltage, then it becomes high. Correct? So when A is 0, then A dash is 1. Okay. When A is 1, then A dash is 0. So just this is the NOT condition, correct? So it changes the signal, it reverses the signal, correct? Similarly, B becomes B naught. So we have separately shown this. B or B dash is means after passing through the NOT circuit, it just changes, it reverses. Okay. Now here we have this particular symbol is for OR gate. Now there is a circle here, it means that it converts, it negates it. It creates a NOT of it. Okay. So if the A prime, A naught and B prime are the input to this NOR gate, this is OR. OR means it adds two values, A dash B dash. So this becomes A dash plus B dash. But when we have a NOT here, so it negates it. Negating means it reverses it. Correct? So add A dash plus B dash and then take the NOT of it. Reverse it. Correct? So now in our truth table, we have A dash plus B dash. For this A dash plus B dash, 1 plus 1 is how much? Is 1. But because of this NOT, it becomes 0. Similarly, 1 plus 0. 1 plus 0 means what? 1. But because of this NOT, because of this NOR gate, or simply adds to signal, but because of NOT on OR, it is what is happening? It becomes 0. Similarly, 0 plus 1. 0 plus 1 is actually 1, but if it is not, then it is 0. 1 plus 1. Achha, 0 plus 0, na? 0 plus 0. 0 plus 0 is 0. Sum is 0. If you note it, then it becomes 1. So see, in all the three cases, the output is 0 only. Only when both are means A dash, B dash are low, or the input signal A and B both are high, correct? 1, 1. Then only output is 1, correct? So this is the final result. So output is 0 if either one of them is low, okay, or 0. And output is 1 only when both are high, correct? Both are on. So this is the entire circuit diagram, truth table explanation for this circuit. Now, if we see the input voltage versus the output voltage, what it does actually, see, it ANDs, means 0 0. If you multiply 0 into 0, what is happening? It is 0. Okay, the characteristic of truth table of AND circuit is it multiplies 0 into 1, it multiplies, it is 0. 1 into 0 is also 0, and 1 into 1 is only 1. So such characteristic, which is actually multiplies the input signal and giving us the result, is the characteristic of AND. So if you are asked that equivalent to this circuit, okay, where we have two NOT gate connected with the NOR gate, so two NOT gate connected with a NOR gate is equivalent to nothing but a AND gate. So this is the symbol of AND. So it simply multiplies, Y is simply AND gate. So if we have to replace this entire circuit by a single circuit, then it is nothing but a AND gate, correct? Thank you very much.